Hi everyone, it's Coach Fred here, and today I'm going to be going over probability on the ACT. So I'm going to apologize now. This one's going to be a little bit longer because I'm going to try to go over everything that you kind of need to know on the ACT. So it could be a little bit longer. So let's stay focused, okay? So on the ACT, you'll be asked to find the probability of something, and I want to make sure that you understand that the probability, and I'm going to use my own words here, my own language, the probability of an outcome is the total positive outcomes. The total positive outcomes for whatever you're asking about all over the total possible outcomes. And we're going to look at that's simple probability, okay? Now, I want to make sure you understand that on the ACT, you're going to be asked using either of the words. They might ask the chances or chance. They could ask the specific probability, or they could even say the likelihood that something's going to occur. All of those words are your key-in, your words that you have to know that mean you're finding the probability. All right, now we have to be careful because while simple probability is just that, finding a fraction, we have to be wary of negative outcome questions. All right, so we're going to look at two examples. First, John is stringing a bracelet and he selects each bead at random from a basket of beads. If there are currently 5 yellow beads, oops, there's a comma there, 10 red beads, 15 green beads, and 20 blue beads in the basket, what are the chances, there's that word, that he will select a red bead? Okay, so remember, I want the probability of a red bead. Okay, so that means I want the probability, I want the number of the total red beads, all the total possible beads. Okay, so I have to add 20 and 10 is 30, 15 and 5 is 20, so that's 50. And red beads is 10, so my probability would be 1/5. I'm going to take a second here and talk about fractions just because it's a great fraction to know. So 1/5 as a decimal is 0.2 or 20%. 2/5 is 0.4, so 40%. 3/5 is 0.6, so 60%. And 4/5 is 0.8, which is 80%. So obviously 5/5 is 1. Those are important fractions to know. All right, let's go back. So we know our probability is 1/5 or 0.2 or 20%. All right, but I said, well, simple probability is just that. It's easy, simple, which is what we just did. We have to be wary of negative outcome questions, something like this. What is the probability that he will not select a green bead? Not select a green bead. Okay, so probability of not green. Okay, so we still have a total of 50 beads, but not green. We have to add up the ones that actually are green, right? So there's 15 green beads. So if I do 50 minus 15, I'm going to get 35 that are not green. So 35 out of 50 or 7/10 or 0.7. Okay? All right, so those are the basic simple probabilities and one with a negative outcome that you have to be really careful of. Now, I put not uppercased to stand, so it would stand out for you, but you've got to be really, really careful about that. All right. So let's talk about impossible events. Impossible events are going to have a probability of 0. So probabilities have to be between 0 and 1, or 0 and 100%. 100% meaning it absolutely will happen, 0% it will never happen, and then 50% is going to be right in the middle, right? All right. Now, let's look at some harder things. The other two things that we have to consider is it an either or probability? Either or means that it's one or the other. So I have more chances of it being true or getting a true outcome. Either or increases the odds that our desired outcome will happen. Why? Well, because we have more possibilities. These are non-overlapping probabilities. So if I were thinking about algebra for a second, non-overlapping probabilities might say something like this. I want the numbers that are either bigger than 4 or less than 2. See, we can see in the diagram there's no overlapping probability. So we have to consider, is it either or? Now, either or probabilities means that it increases the odds. So if the probability of the first thing occurring is a half and the probability of the second thing occurring is a half, we're going to add the probabilities. And in this case, we get 1. So yes, our probabilities kind of went up. All right. Then we have combined probability. These are the harder questions, so they're going to be towards the end of the test. But we want to know what are the odds of 2 or more events happening, both of them happening. So it means and they're happening. So that's when we have overlap. So if I go back to that number line from algebra, we want numbers greater than 2 and less than 4. So remember, we looked with ands, we looked at overlap. Now, combined probability is harder, which means that it's going to look a lot, we're going to be multiplying probabilities because that's going to make the probability of it happening smaller because they both have to occur. So if I had 1/2 for the first event and 1/2 for the second event, I'd actually be multiplying them, giving me 1/4. All right, let's decide what this next example would be. You roll 2 cubes, and I'll say a cube is got 6 sides, okay? So 1 through 6. What's the probability you roll a pair with 5 on both? So both means and, so I have to look at the probability of each roll. If I roll a cube and it's got 6 sides, then I could roll 1 through 6. So the probability that the first one lands on a 5 is 1 of 6. The probability it rolls on a 5 on the second is 1 of 6. And because we want both to be true, this is and, so this is combined probability, so we multiply. So the probability of this occurring is 1/36. Okay, so those are some of the basics of probability. Let's look at some questions. To make a 750-piece jigsaw puzzle more challenging, a puzzle company includes 5 extra pieces in the box, along with the 750 pieces. And those 5 extra pieces do not fit anywhere in the puzzle. Oh, hate that. If you buy such a puzzle box, break the seal on the box, and immediately select one piece at random, what is the probability that it will be one of the extra pieces? So we want the probability of it being an extra piece. Okay, well, that's total outcomes. Now, that means there's 755 pieces in the box, and only 5 of them would be true, so my probability would be 5/755. Just hate it when there's those extra pieces and we can't figure out where they go. All right, probability can also come in graphs, lots of times with circles and percentages or ratios, and we want to be really careful and look at what the ratios represent. Anytime you're given a ratio on this test, please, please, please make sure that you know what that ratio means. Is it a part-to-part ratio or a part-to-whole ratio? All right, so the circle graph below shows the distribution of registered voters by age for a community. Registered voters are randomly selected from this distribution to be called for jury duty. What are the odds in the age range to not in the age range that the person called for jury duty is in the age range of 25 to 35? All right, so first, in the age range. So 25 to 35 is that the black, so that's 42%. Not in the age range would be 100 minus 42%, which is 58. So that would be 42 to 58, which is part to part. I would simplify that by dividing by 2, and that's going to give me 21 to 29. Now, we had to know it was part to part versus part to whole because if it was part to whole, it could give me a different simplified ratio. All right, I want to make sure you also understand that sometimes using math is easier, but sometimes plugging in the answers is easier. And we've talked about that as a strategy in one of my videos, but now we're going to look at it in action. I'm going to show you both ways. Again, this is why this video is a little bit longer. So if you need a break, press pause, take that break right now, okay? If not, let's just keep going. A bag contains 12 red marbles, 5 yellow marbles, and 15 green marbles. All right, how many additional red marbles must be added to the 32 marbles already in the bag so that the probability of randomly drawing a red marble is 3/5? Okay, so if this were algebra, I would say you'd have to set your variable, and it would be based on the question being asked. The question asks me for how many additional red marbles must be added. Okay, so I'm going to let x equal the additional number of additional red marbles. Okay, so we have 32 already, okay, and we have 12. It's saying how many more must be added. So if I add that to the 12, I have to add it to my total. And we need that to equal 3/5. So there's some algebra. That's the algebra to this. All right, so the algebra would say we clear fractions or we cross multiply, giving me 60 plus 5x equals 96 plus 3x. We solve the equation by balancing, and we get 2x equals 36, so x equals 18. How many additional red marbles must be added? Well, 18. Okay, so that's using algebra. That actually took some time. I want to talk about this idea of plugging in answers. So if we go back to our original proportion, 12/32, we know that no matter what we add, we want the ratio to simplify to 3/5 because that's what ratios are. They are fractions that, when simplified, all are going to be equal to each other, equal ratios. So I'm going to go through the answers. So if I add 13, I get 25/45, which does not simplify to 3/5. So 13 is out. So then I add 18. Okay, so if I add 18, that's going to give me 30/50, which does simplify to 3/5. And so my answer would be 18. Look how fast that worked. All right, so I always want you to think about the idea that, especially if the answers are whole numbers, because I'm going to really quickly scan those to see that, that might be a place where you could plug in your answers. All right, guys, hope you're still with me. A few more. I want you to try this one because this is an example of what we just did. I want you to pick your method, either algebra or proportions, and try it. Press pause and come back. Okay, you're back. I actually loved the plugging in answers here. So I had 18 marbles that were already in the bag. We wanted to add red marbles to it. Okay, it contains 6, 5, and 7. How many additional red marbles must be added? So I already had 6, and I wanted to get a ratio of 3/5. So I plugged in answers. So plus 12, plus 12. That gives me 18/30. Wow. The first answer simplified to 3/5, so my answer is 12. All right, just a few more. Okay. Now, I find this really interesting. This is question 59 on a test that I looked at. One of the hardest questions, and it's probability. And the probability questions really just involve addition or multiplication. So as part of a probability experiment, Elliot is to answer 4 multiple choice questions. For each question, there are 3 possible answers, only one of which is correct. You guys remember that. You take multiple choice question tests sometimes. If Elliot randomly and independently answers each question, what is the probability that he will answer the 4 questions correctly? All right, so each question is independent. So we're going to be multiplying because the probability is going to go down. And here's my 4 questions. All right, so for the first one, 1 of 4 is correct. I'm sorry, 1 of 3 is correct. There's 3 possible answers. 1 is correct. So 1/3, 1/3, 1/3, and 1/3. So 1/81. Really not all that hard. You can do that. All right. Histogram. I give you this beautiful histogram. I see that this histogram says the blood type of 150 people were determined for a study as shown in the figure. We've got the number of people and the blood type. I see that they put the numbers right above, okay? If one person from this study is randomly selected, what is the probability that this person has either type A or type AB, okay? All right, so 67, they have 67 over 150 or 6 over 150. So that gives me 73 over 150. And that's a place where we add the probabilities. Gave me more options. It's one or the other. All right. Now this, I think, is probably one of the harder questions, okay? So only 10th, 11th, and 12th grade students attend Washington High School. The ratio of 10th graders to the school's total population is 86 to 255. So I can see that that is 10th graders to the whole population. So 86 to 255, and I'm going to label that 10th grade, okay? The ratio of 11th graders to the school's total population is 18 to 51. I didn't really like that one because the bottom was different than 255, so I decided to multiply and make them the same, and I did that by multiplying by 5. So that gave me 90 over 255. If one student is chosen at random from the entire school, which grade is the student most likely in? Well, I need the 12th grade. And if it's out of 255 and I already have 90 and 86, 90 plus 86 is 176. And if the ratio is 255, well, if I do 255 minus 176, that's going to give me 79. That means the ratio for 12th graders could be 79 to 255. So if one student is selected at random from the entire school, which is the grade is the student most likely in? Well, it would have to be 11th because they have more students in the class, as you can see from the fractions. So 11th grade. That's a little challenging. All right, last question. To get a driver's license, an applicant must pass a written test and a driving test. You remember, don't you? Past records show that 80% of the applicants passed the written test, and 60% of those who passed the written test passed the driving test. Based on those figures, how many applicants in a random group of 1,000 applicants would you expect to get a driver's license? All right, well, 80% passed the written test, so that's 800. Right? And then 60% of those who passed that test passed the driving test. So I'm going to multiply that by 0.6, which is going to give me 480. All right, guys, I know that was a long video, but hopefully it was a really good review of probability and all the things that you have to consider when you're taking the ACT. And hopefully you'll let me know if there are any other questions you have or if you like the video. Thanks so much. Have a great day.